Hi, this is the next video for Year 2 Pure. We're on with integration still, and we're looking at substitution, working towards exercise 11E. Now, integration by substitution turns a nasty integration into a more straightforward one. And the first example gives a good demonstration of using different substitutions. What we're going to do is we're going to turn an integration in x into an integration in u. Okay, so I can see that I can replace root 2x plus 5 with root u. I need to replace this x. I need to get rid of all my x's and replace them with functions of u. So let's make x the subject here. U minus 5 over 2. And also dx. I need to make dx into some function of du. Well, if I differentiate u, du dx is 2. So of course dx is a half du. So I'm going to replace x with u minus 5 over 2. I'm going to replace root 2x plus 5 with root u, and I'm going to replace dx with a half du. So let's do that. U minus 5 over 2 times by root u times by a half du. All I'm going to take, as I like to, I'm going to take my constants out. Half times a half is a quarter. So a quarter, u minus 5 times u to the half du. I expand those brackets and I get u to the 3 over 2 minus 5u to the half. And that is a straightforward integration. Increase the power, divide by the power. So a quarter of e to the 5 over 2 over 5 over 2, or times by 2/5, minus u 5u to the 3 over 2 divided by 3 over 2. So let's sort that out. 2 over 20, so that's u to the 5 over 2 over 10. And that will be 10 over 3, won't it? 10 over 3u to the 3 over 2. Not forgetting that I actually want my answer to be in x because the question was in x. So replace my u with 2x plus 5. I've got my 10. There you go. Straightforward enough. In the book, correctly, they've simplified that to, oh, what have they simplified that to? Oh, I didn't do 4 times 3, did I? So that's actually 10 over 12, which means that's 10 over 12, so of course that would simplify to 5/6. Yes, of course it would. The example is a good example to show how I don't necessarily have to use that substitution. I've got this same question with a different substitution. Let's write it out again. U squared is 2x plus 5. Now, remember when I differentiate by x, if my expression is not in x, I use my implicit differentiation. So differentiate with respect to u multiplied by du dx. So u du equals dx. So I'm going to replace my dx with u du. My habit generally is do the dx first, see if anything cancels out. Now, clearly I can see that the square root of 2x plus 5, well, that's the square root of u squared, which is u. So I've got u times by dx so it's x times by u squared du. I need to get rid of this x, so I use my original expression. So u squared minus 5 over 2 is x. So this will give me u squared minus 5 over 2 times by u squared du. I'm going to take my half out because I like to. Multiply out my bracket, u to the 4 minus 5u squared du. And of course then I can just, this is a straightforward integration. U to the 5 over 5 minus 5u cubed over 3. Now u to the 5, but I've only got squared. Let's have a think about that. U to the 5 is u squared to the 5 over 2, isn't it? Over 5. U cubed is u squared to the 3 over 2. So I had to use my brain a little bit. But now, of course, you can see I'm going to end up with the same answer. Half of u squared, which is 2x plus 5, minus 5 over 3 2x plus 5 to the 3 over 2. Which, if you compare it to the previous answer, I could take out my half and end up with the same thing. So it doesn't really matter. There's not a unique substitution that works. It's just about using the substitution which is convenient. And I think, although the integration might have been slightly more difficult for this, but then the substitution at the end was more straightforward. The integration here was more straightforward, but then I had to use my brain a little bit more with my powers, so there's some sort of payoff there. But that's the procedure. Given the substitution, and 99.9% of cases I am given a substitution. Given the substitution, replace dx and anything that's obvious. Get rid of all the x's, simplify, integrate, put your x back in. Now these were both indefinite. Remember, indefinite means I don't have any limits, so I forgot my plus c. The next example is indefinite again. So let's do that. Example 13. Cos x sine x 1 plus sine x cubed. I'm not going to attempt to expand anything. The first thing I'm going to do is try and get rid of these x's. So if u is sine x plus 1, well, I can see straight away that's going to turn into u cubed, which will be easier to integrate. I can see that my sine x will probably be u minus 1. If I differentiate, sine x differentiates to cos x, so of course dx is, I'll leave it as 1 over cos x du. Now let's do the obvious ones. I'll leave the cos x in for the time being. Sine x is clearly u minus 1. 1 plus sine x cubed is u cubed. Dx, well that's 1 over cos x du, and this often happens. Cos x divided by cos x is 1. So this integration has suddenly simplified to u minus 1 times u cubed du. Oh, that's a lot easier. Expand the brackets, simplify, integrate. U to the 5 over 5 minus u to the 4 over 4. Not forgetting to sub in, because my final answer needs to be in x. Sine x plus 1 to the 5 over 5 minus sine x plus 1 to the 4 over 4. And I'm not going to attempt to expand these and simplify. Okay, let me just pause for a sec. I've had to think about this. I'm leaving example 14 because this is actually, we haven't seen this at A level. This should be in the further maths books. I'm leaving example 14. You can look at it yourself if you want to, but I've got to focus on 15. Example 15. That noise you can hear is the dog making her bed, by the way. I'll just pause it till she's finished. Okay, she's settled down, so let's carry on. Interestingly, for this example, I'm not given the substitution. I don't want to worry too much about that. One, I think it's quite obvious what the substitution should be, but also I haven't seen an exam question where we're not given the substitution. It becomes fairly obvious if we've chosen the correct substitution, and as I say, in a question like this, it's pretty easy to see what the substitution would be. So let's differentiate to get an expression for dx. Oh, that's handy. du equals dx. It's obvious, isn't it, that x is going to be u minus 1. Now remember that these two values are x values. We'll discuss that when we get to it. So let's leave this as an x value for the time being. X, that's just going to be u minus 1 times by u cubed du. Straightforward enough. Oh, sorry, I'll expand it first. U to the 4 minus u cubed du, and I'm going to leave these values as x. U to the 5 over 5 minus u to the 4 over 4. Again, remember these values are x values. So I have a choice here. I can either turn these into u values, or I can write out my integration in terms of x. At the moment, I haven't done either, so I've got an expression in u, but values of x, and that's not going to work. Clearly, because it's such a simple substitution, sorry, it's easy to replace my x values with u values. If x is 0, u is going to be 1. If x is 2, u is going to be 3. So I'm going to replace my x values with u values because that seems to be the most sensible thing to do here. And then it's back to year 1 integration. Substitute in one, substitute in the other. 3 to the 5 over 5 minus 3 to the 4 over 5. Take away 1 to the 5 over 5 minus 1 to the 4 over 5. I haven't worked this out, but apparently the answer is 28.4. I've no reason to doubt that. Just to demonstrate, I'm going to get my calculator and use the calc button. If I'd have gone x plus 1 to the 5 over 5 minus x plus 1 to the 4 over 4, if I'd have left my x values in and replaced my u's with my expression in x, you would hope I'd get the same thing, wouldn't you? 2 add 1 to the 5 over 5, 2 add 1 to the 4 over 4, and then 0 add 1. So you can see that I'm going to get the same value. Let's do the last example then. 0 to pi by 2, so not forgetting we're in radians here. Of course, any calculus with trig will need to be in radians. Not given a substitution again, but as I say, I think it's quite obvious. Let's make u equal 1 plus sine x, and we know what's going to happen here. Du dx is cos x. So du over cos x is dx. So clearly my du over cos x will cancel out with my cos x. Not forgetting that my limits are x. Let's leave them in x for the time being. X equals 0 to pi over 2. Well, as I say, replace my dx with du over cos x. So clearly it's going to cancel with that cos x. So I really only need to replace my 1 plus sine x with my u. Again, I like to write my x down there just to remind myself these are still x values. So u to the 3 over 2 over 3 over 2. And there are my x values. Okay, x, u, if x is 0, well, u is 1 plus sine x, sine of 0 is 0, so u must be 1. If x is pi over 2, think about my sine graph, there it is, pi over 2, sine pi over 2 is 1, plus 1 is 2. I think it's easier, isn't it, to put in my u values here. So I will. U to the 3 over 2 over 3 over 2 between 2 and 1. And I don't need to write u equals here because, because it is u. So I'll sub in 2 to the 3 over 2 over 3 over 2 minus 1 to the 3 over 2 over 3 over 2. So it's 2/3 of root 2 cubed minus 2/3 of 1. To take out a factor of 2/3, root 2 cubed, that's 2 root 2. Done. Have a go at 11e, but like I say, I'm not too fussed about question 7. You can make that one optional. Okay, enjoy.